Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 2 of 10 good problems on the chapter of compound interest. I hope you have watched the set 1 where I solved 10 good problems on the chapter of compound interest. So far I have discussed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you have not watched all the theoretical videos on the compound interest in the other playlist CBSE Maths 8 RS Agarwal, I strongly suggest and request that you watch those videos also to maintain the continuity of your study on this chapter. So this video is part of the playlist CBSE of the playlist Maths 8 HOT. HOT stands for High Order Thinking Problem, where I come up with 10 good problems which are relatively harder than the problems we solved from the textbook of Author R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos for the first time, or if you are visiting my channel for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 10 good problems of set 2 on the chapter of compound interest. Okay, so I have the problems on the left hand side. I hope the fonts are big enough so that you can read the problems properly. Also, the link to the PDF of this problem will be there in the description below. So after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you as a future reference. So let's get started in solving the problems. The first problem says that if the amount on the principal of rupees 6,000 is written as 6,000 multiplied by 1 plus 5 by 100 to the power 3, and the compound interest payable half yearly, then rate of interest per annum and time in years are. Okay, so my as far as the general formula is concerned, that I discussed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you have not watched those the last two videos in that playlist on the chapter of compound interest, please look those videos, watch those videos. The general formula for the amount based on compound interest, where the rate of interest per annum is same throughout the time period of time, the formula was amount A is equal to the original principal P multiplied by 1 plus R dash by 100 to the power small n, and multiplied by 1 plus the fraction A by B multiplied by R dash divided by 100. Now what is R dash? Now P is the original principal. What is R dash? R dash is based on the R, the unit of time. Its formula is RU by 12. Basically, R dash will be the rate of interest based on U. U is the unit of time. Also, this unit of time is termed as conversion period. That is, what is the duration after which every calculation of interest will occur. So, in this problem, it is given that the compound interest payable half yearly, that is, after every 6 months, the interest will be calculated. So U is basically in this problem, U is equal to 6 months. U, as per the formula and my discussion, U is in months. So R dash will be R multiplied by U is 6 by 12. This is equal to R by 2. So whenever the interest is compounded half yearly, the R dash will always be R by 2, where the R is the given principal per annum. Okay. Now, what will be small n and A by B? Small n and A by B is based on the value of T multiplied by 12 divided by U, where T is the time period in years and U is the unit of time, which is 6 months in this problem. In this problem, we have to find the rate of interest, that is R. We have to find R and the T in years. Okay. Now, so the small n and the fraction a by b is based on the value of t multiplied by 12 divided by u. So this is basically this t multiplied by 12 divided by u when expressed as a mixed fraction. It is expressed as a mixed fraction. We get n and a by b, which is equal to n plus a by b. If we express the value of t multiplied by 12 divided by b divided by u as a mixed fraction, and if that mixed fraction is small n and a by b, so this small n and a by b is used in the formula. Now we do not know, so we have to find the small n and the fraction a by b to get t, and also we have to find the r. Now it is given that in this problem p is equal to 6000. Also a is given as 6000. Now if the original principal is 6000, then the amount will be we know is 6000 multiplied by 1 plus where r is the rate of interest given as per annum. This will be, since r dash is equal to r by 2, we can write r in the formula, in this formula, general formula. In place of r dash we are writing r by 2, since we have r dash equals to r by 2. r by 2, this power is given as so the amount is given as the amount will be as per the principal given, that is 6000, and r dash will be r by 2. So we will have small n multiplied by 1 plus a by fraction a by b, and this r dash is equal to r by 2. So we have this. So this should be the formula of the amount as per the given information based on our general formula. But this is given to be equal to 6000 multiplied by 1 plus 5 by 100 to the power 3. Now definitely we can say that since in the given formula for the amount we are having only 6000 multiplied by 1 plus 5 by 100 and this power 3. So this term from the general formula, this term must be 0. This term must be 1. This term must be 1. So this term must be 1 based on the given expression of the amount, that is 6000 multiplied by 1 plus 5 by 100 to the power 3 must be 1. Must be 1. So this will imply that the fraction a by b is equal to 0. Okay. So this implies we must have from our general equation we are having the amount to be 6000 multiplied by 1 plus r by 100, r by 200, r by 200 to the power n. This is the formula for amount as per our general formula, and this is given to be equal to the given expression, that is 6000 1 plus r by 1 plus 5 by 100 to the power 3. So 6000 cancels out. Now comparing the LHS and RHS, we must have we must have r by 200 is equal to 5 by 100, and n should be equal to 3. N should be equal to 3. This implies R should be equal to 200 multiplied by 5 by 100. This is equal to 10. So R is 10% per annum and N is 3. Now remember, if N is 3 and the fraction A by B is 0, now T multiplied by 12 divided by U must be equal to N and A by B. This is equal to N we have found to be 3 and the fraction fraction is 0. So we have T multiplied by U multiplied by 12 divided by U is equals to 3. If the fractional part A by B is 0, then obviously N, this will be equal to N if the fraction part is 0, if this is 0. Or this implies T multiplied by 12 divided by U we know is 6 is equal to 3. This implies T is equal to 6 multiplied by 3 divided by 2 divided by 12. So this is equal to 3 by 2 years, which is equal to 1.5 years. 1.5 years. So the time is 1.5 years and the rate percent per annum is 10% per annum. So the answer is choice D. The answer is choice D. Okay, let's do problem number 2. At what rate will rupees 64,000 amount to rupees 68,921 in 1.5 years? Interest being payable half yearly. So the principal is given to be rupees 64,000 and the amount is given to be rupees 68,921, and it is given that interest being payable half yearly, which means the unit of time is 6 months. Unit of time is 6 months, or the conversion period is 6 months. T is given to be 1.5 years. This is equal to 3 by 2 years. The first thing, we have to find the rate of interest. Now we know that so the R dash, we have R dash in our general formula. So R dash will be R U by 12. This is equal to at what rate? So we have to find the rate. Okay. So this will be R. If R is the rate of interest per annum, then R dash is RU by 12. U we know is 6, and we have R by 2. Okay. And we need the small n, as we know. We need small n and the fraction A by B, which we will have from T multiplied by 12 divided by U, where T is in years and U is in months. So T is 3 by 2. This multiplied by 12 divided by U is 6. This is equal to 3 multiplied by 12 divided by 12, this is equal to 3. Now this is equal to t multiplied by 12 divided by u should be expressed as n, as a mixed fraction n and a by b. So this implies that n should be equal to 3 and the fraction a by b is equal to 0. Now we have amount from the general formula. Amount equals to principal P multiplied by 1 plus r dash by 100 to the power small n and multiplied by 1 plus the fraction a by b r dash by 100. This will be equal to P r dash is equal to r by 2. So we have r by 200 to the power small n, and since a by b, the fraction a by b is 0, we have found the fraction a by b to be 0. This part on the right hand side in the formula, the third factor, this factor will become equal to 1. So this is now equal to P multiplied by 1 plus r by 200 to the power 3, because n is 3. So this implies the amount is given to be 68921. P is given to be 64000, and we have multiplied by 1 plus r by 200 to the power 3. So this implies 1 plus r by 200 whole to the power 3 is equal to 68921 divided by 64000. Now we have to somehow express the right hand side as an exponential term with the power as 3, and then we can equate the base from both the sides, and then we can solve for r. Now the right hand side, the denominator 64,000 can be written as 40 cube. Can be written as 40 cube. We have to somehow express the numerator of the right hand side as a cube, as a perfect cube. So how do we find the cube root of a number? One way is to, is it divisible by, we can do prime factorization. Now cube, any number whose cube ends with the digit 1 should end with the digit, it can end with digit 1 or 49. No. It should end with digit 1. What is the cube root of the number 68921? That cube root should end with the digit 1. 339. No, it can also end with the digit 3, because 3 into 3 cube is 81. 7, 50, 51. I'm sorry, friend. I do not want to waste time in finding the cube root. I hope you will be able to figure it out. What is the cube root of the number 68921? I'm using a calculator. I'm really sorry for this. I shouldn't be using a calculator, but uh, cube root is 41. Okay, so this is 41 cube. So this is the right hand side is 41 by 40 whole cube. So now we see both the left hand side and the right hand side are in exponential form and the powers are same. So the base must be same. So we will have 1 plus r by 200 is equal to 41 by 40. So this implies 1 minus this implies r by 200 is equal to 41 by 40 minus 1, which is equal to 1 by 40. So this implies r is equal to 200 divided by 40, which is equal to 5. So r is the rate percent per annum is 5%, and hence the correct choice is A. A is the correct choice. Okay, let's do problem number 3. If rupees 5,400 is lent at 5% rate of interest per annum, interest being compounded annually for 3 years, then the principal for the third year is, Now, so this is a little conceptual problem. What will be the principal for the third year? This means the principal, if you know the basic fundamentals of how the compound interest are calculated at the end of every unit of time, that is, if the interest is being compounded annually, then interests are calculated at the end of every year. So what the principal for the third year will be principal and for the compound interest, the current principal to calculate the interest for a particular unit of time, the principal considered is the amount that was computed in the previous unit of time. So principal for third year, since the interest is being compounded annually, interest will be calculated at the end of every year. So principal for third year, that is the principal to calculate the interest for the third year should be equal to the amount after 2 years. So now we have to find the amount after 2 years. So what is given? P is given to be rupees 54,400. R is given to be R is equal to 5% per annum, and interest is being compounded annually for 3 years. Okay, so we just need the principal for third year should be equal to the amount after 2 years. That is the amount calculated at the end of the previous year. So we know that the special case of the formula of our general formula, we know that of the general formula for the amount is equal to A is equal to P multiplied by 1 plus R dash by 100 to the power small n multiplied by 1 plus the fraction A by B multiplied by R dash by 100. Now, for the special case when the interest is being compounded annually, this simplified formula, mm, and the period and the time is, let's say, and the time is do not have any fractional part, that is the number of unit of time, do not have any fractional part, that is t multiplied by 12 divided by u is a integer. Then since we have to find the amount after 2 years, so t is equal to 2 years, t is equal to 2 years, and u is equal to 12. Since the interest is being compounded annually, we so therefore this implies the r dash will be equal to, since the interest is being compounded annually, r dash will be equal to r dash will be equal to r, which is equal to 5. And to find the small n and fraction a by b, we have to find the value of t multiplied by 12 divided by u. This is equal to, t is 2, 12, and u is also 12. So this is equal to 2. So t multiplied by 12 by u is equal to 2. From 2 we can get the value of small n and a by b, because 2 when represented as, if we represent 2 as the fraction, mixed fraction n and a by b, this will imply n is equal to 2 and the fraction a by b is equal to 0. So this implies that the amount after so after 2 years, the question has asked to find the principal for the third year, which will be equal to the amount after 2 years. This is the fundamental concept of compound interest. That is, the current principal becomes the current principal considered is the amount computed in the previous unit of time. So after 2 years, amount is equal to the original principal, which is 5400, multiplied by now 1 plus in the formula r dash is equal to r dash is equal to, so we have r by 100 and n is equal to 2, and since the fraction a by b is 0, this part is 1, so we have multiplied by 1. So this is equal to 5400 multiplied by 1 plus r is 5 by 100 square. So this is equal to 5400 multiplied by 1 plus this is 1 plus 1 by 20 square. This is equal to 5400 multiplied by 1 plus 1 by 20 is 21 by 20. So we have 21 square, 21 by 20 square. This is equal to 5400 multiplied by 21 multiplied by 21 divided by 20 multiplied by 20. So 0 cancels out and 4 divides 54. No, 4 will not divide 54. So 2, 4 and 27. 27, okay. So this is equal to, how much is, I am using again the calculator, I am really sorry for this. 21 multiplied by 21 multiplied by 27 is equal to 21 multiplied by 21 is equal to 441 multiplied by 27 is equal to 11907 divided by 2, which is equal to 5953.5. So this is the amount after 2 years, which is also the principal for the third year, and the question has asked the principal for the third year. So the correct choice is D. D is the correct choice. Okay, let's do problem number 4. In how many years will rupees 10,000 amount to rupees 20,736 at 40% per annum when compounded half yearly? Okay, so P is given to be 10,000. Amount is given to be 20,736. We have to find how many years, that is, we have to find T. And all the choices are integers except the choice B, which is a fraction, mixed fraction. Okay. When compounded half yearly. Okay. So U, it is given the interest is compounded half yearly. So U, that is a unit of time, or the conversion period is 6 months. And the rate is given to be, also the rate percent per annum is 40. So we have to find the T, that is the time period. Now, so from first of all, what is R dash? R dash is equal to R U by 12, which is 40 multiplied by which is R U is 6 by 12. This is R by 2, and so the general formula is then compounded half yearly. Now, whenever you're asked to find the time period of time, that is T, I think it will be it is better that you assume that the T time will be the time will be the number of years will be an integer, so that you can ignore you can consider the fraction a by b as 0. So the general formula is amount is equal to P multiplied by 1 plus R dash by 100 to the power small n, and this is multiplied by 1 plus a by b R dash by 100. Now, whenever in any problem on compound interest, you are asked to find how many years, the time period T, then if you want to use this general formula, it is better that you consider the fraction a by b as the 0. Otherwise, it will be difficult for you to find small n and a by b, because to know the time period T, you have to know the small n and a by b, because we know that small n and a by b is coming from the T multiplied by 12 divided by u, which in this case is T multiplied by 12 divided by 6, which is equal to twice T. The small n and a by b, that is twice T, when represented as n, as a mixed fraction n and a by b, then we are using this formula. Now, from the formula, From the formula, it will be, if you consider the fraction a by b, it will be difficult to compute, evaluate, or define the value of small n and a by b, because what we will have is that, so this is equal to p multiplied by r dash is equal to r by 2. So we have r by 200 to the power small n, and we have 1 plus a by b, this is r by 200. Now this implies we know the amount and the principal. The amount is 20736 is equal to, principal is 10000, and multiplied by 1 plus r by 200 to the power small n, and 1 plus a by b r by 200. We have this. Now usually to solve this kind of problem where you have to find the power, you have to find the time period t, essentially you have to calculate, somehow find the value of small n, that is the power. Now if you consider this factor to be not equal to 1, then it will be difficult to solve the small n and a by b. So it is better you consider the fraction a by b to be 0. Only when you are asked to find the time period, period of time, that is t, and if you are using this general formula. So if we consider the fractional part a by b to be 0, then this whole part, this part will become 1. So we are having, now the expression will be a little simpler. We have this. We have this. Now we can easily solve for n. Now what is r? R is not, okay, so r is given. So this is equal to 10,000. 1 plus r is 40. So 40 by 200 to the power n. This is equal to 10,000. 40 by 200 is 1 by 5 to the power n, and this is equal to 10,000, and 6 by 5 to the power n. 6 by 5 to the power n. Now to calculate the power n, to find the value n, we have to simplify the equation further, and we have to bring the factor 10,000 from the right hand side to the left hand side. So we have 20736 divided by 10,000 is equal to 6 by 5 to the power n. Now somehow we have to express the left hand side as a power of 6 by 5, because then only we can solve for n, because on the right hand side the exponential term, we have the base is 6 by 5. Now how can we so the denominator on the left hand side is 10,000, it's a power of 10, it's a power of 10. So somehow let's see, so this thing, so the denominator is 10 to the power 4, and the numerator is 20736. This is equal to 6 by 5 to the power n. Somehow on the left hand side we have to make the base 6 by 5. Now 10 to the power 4, 10 can be factorized as 2 multiplied by 5. So this is 2 multiplied by 5 whole to the power 4. So this is 2 to the power 4 multiplied by 5 to the power 4. And the numerator is 20736. So we are having this. We have to do a little bit of simplification on the left hand side. Now what is we have numerator 20736, and what is 2 to the power 4? 2 to the power 4 is 16. We have 16 multiplied by 5 to the power 4. Somehow we have to make express the left hand side as a power with the base 6 by 5. That is the main intention, main objective. Then only we can solve for n. Now if we divide 20,736 by 16, what do we get? 1, 4, 47, 2, 32, 15, 153. Let's divide step by step. Let's divide first by 4. So 4, and we have, if we divide 20,736 by 4, we have 5, and then 1, 8, and 4. If we divide again 4, we have 1, 8, 4, 2, 9, 6, 1296. Now 1296 is the numerator, that must be expressed as a power of 4, power of some natural number where the power is 4. So let's quickly do the prime factorization of 1296. So 4, 3, 2, 4. Okay, 324. So 4, 81. Okay. So the factors are 1296 is 4 into 1296 is equal to 4 multiplied by 4 multiplied by 81. Now 4 into 4 is 16, which is 2 to the power of 4, and 81 is 3 to the power 4. So this is equal to 6 to the power 4. Okay. So this becomes now 6 to the power 4 divided by 5 to the power 4 is equal to 6 by 5 whole to the power n. So this is 6 by 5 whole to the power 4 is equal to 6 by 5 whole to the power n. Hence we can say from here that n is equal to 4. So if n is equal to 4, t, what will be t? Remember that twice t is equal to n. If we have considered the fractional part a by b to be 0, so this will be equal to n. This is equal to n. So we got twice t is equal to 4. So this implies t is equal to 4 by 2, that is equal to 2. So t is 2 years, and hence the correct answer is C. Okay, let's do problem number 5. Find the amount and the compound interest on rupees 3,600 for 2 years, compounded annually. The rates of interest are 8% during the first year and 10% during the second year. So so we are having different rates of interest for different years. We have to find the compound interest for 2 years, and in the first year the rate is 8%, and in the second year the rate is 10%. So we have already discussed the general formula for computing the compound interest on a principal for having where the rates are interest is being compounded annually and the rates are different for different years. So the formula is A is equal to amount is equal to P multiplied by 1 plus x by 100 to the power x by 100 multiplied by 1 plus y by 100, where the rate is x% per annum for the first year and y% per annum for the second year, and P is the original principal, and this is the amount after 2 years. So if we put the values, it has asked to find the amount and the compound interest on 3600. So P is 3600 and the rate of interest for the first year is given to be 8. So we have 8 by 100, and the rate of interest for the second year is given to be 10. So we have 1 plus 10 by 100. Okay. So this is equal to 3600. 1 plus 8 by 100 is 2 by 25, and 1 plus 10 by 100 is 1 plus 1 by 10. So this is equal to 3600 multiplied by 1 plus 2 by 25 is 27 by 25, and we have 11 by 10. So 1 0 cancels out, and 25 5 5 5 7 720. No, why 720? This is 360 divided by 5 is 772. Okay, and so we have to calculate this. I'm again using the calculator. I'm really sorry for this, but this kind of computation you must have to do manually yourself. So 72 multiplied by 27 multiplied by 11 is this, divided by 5 is 4276. This is 4276.8. This will be the amount. So the answer is choice A. The answer is choice A. So this is the formula for the amount on the principal P, where the interest is compounded annually and the rates are x% for the first year and y% for the second year. So this is the amount for 2 years. For 2 years, where in the first year the rate is x% per annum, and in the second year the rate is y% per annum, and P is the original principal. Okay. Let's do problem number 6. A certain sum quadruples. Quadruples means becomes 4 times. So a certain sum quadruples in 3 years at compound interest, interest being compounded annually. In how many years will it become 64 times itself? In how many years will it become 64 times itself, meaning the rate of interest will remain the same. So in this problem, the rate is not given. A certain sum quadruples in 3 years. Okay, quadruples in 3 years at compound interest, interest being compounded annually. Now, whenever now we know that the general formula for the amount is A, where for the case where the rate of interest is same throughout the time period of calculation of the interest, it is A equals to P multiplied by 1 plus R dash by 100 to the power small n multiplied by 1 plus a by b, the fraction a by b r dash by 100. Now, when the for the special case, when the interest is being compounded annually and the period and the time t is years, is in years, that is, it is an integer years, it does not have any fractional part, then this will become when a by b is equal to 0, when a by b is equal to 0 and u is equal to 12 months, that is, the interest is being compounded annually. This formula becomes p 1 plus the r dash will become equal to r, so r by 100 to the power n. Because the fraction a by b is 0, this part will be equal to 1. So we have this simplified formula for the case where interest is being compounded annually and the time period and the period of time period is in complete as a whole into whole years. It does not have any months or any fractional part. Now it is given that a certain sum quadruples. So we are assuming that the a certain sum is p, that is the principal, and the rate of interest per annum is r. So it is given in the first case that a certain sum quadruples in 3 years. So quadruples means the amount becomes 4 times. So we must have 4p is equal to p multiplied by 1 plus r by 100 to the power n. Now n is given to be a certain sum quadruples in 3 years. So n is 3. So we have this. From this we can, as you can see, we can solve for r, because p cancels out and we have 4 is equal to 1 plus r by 100 cube. Okay, now we having this. Now from this we cannot easily find the value of r. We cannot, because we have to find the cube root of 4, which is not an integer. 4 is not a perfect cube. So cube root of 4 will not be easy to find. We cannot find the cube root of 4. So let us keep this equation, give this equation a number, that is 1. Let this be equation 1 or result 1, where we know that 1 plus r by 100 whole cube is equal to 4. Now let's see, it is asking in how many years will it become 64 times itself. Okay, so let in t years, let in t years p, in how many years it will become 64 times itself. So let in t years, let in t years sum becomes 64 times itself. Becomes 64 times itself means that the amount becomes the 4 times the original principal. So for this case we must have amount will be 4 times 64 times the sum, that is 64 p is equal to p, and we have 1 plus r by 100 to the power t, because we are assuming that in t years the sum will become 64 times itself. So if the original sum is p, the amount will be 64p and the rate of interest is same, and we are having this. From, let this be 2, from the equation 1 and 2 we have to find the value of t. Okay, so we can further we can further from this equation, if we cancel out p, we get 64 is equal to 1 plus r by 100 to the power t. Okay, let this be equation 2. Now we can divide the equation 1 and 2. Somehow we could divide equation 1 and 2, then we will get, let's see what we get from, let's say, let's divide the equation 2 by 1, implies that 64 by 4 is equal to 1 plus r by 100 to the power t divided by 1 plus r by 100 to the power cube. We have this. Okay, so this implies 16 is equal to, using the laws of exponents, the right hand side becomes 1 plus r by 100 to the power t minus 3, to the power t minus 3. Now, okay, now one thing, we know the value of 1 plus r by no, let's do one thing. How do we, from the question 1 and 2, how do we get the value of t? So, so this implies if we 64, if we do a cube, if we take the cube of both the sides of equation 1, we get 4 cube is equal to 1 plus r by 100 to the power 3, and this whole to the power 3. This implies 64, the left hand side becomes 4 cube is 64 is equal to 1 plus r by 100 to the power 9, to the power 9. Now let's remove this part. So so we have 64 is equal to 1 plus r by 100 to the power 9, and also from equation 2 we have 64 is equal to 1 plus we have 1 plus r by 100 to the power t. So we can say that 1 plus r by 100 to the power 9 is equal to 1 plus r by 100 to the power t. Since both the sides of the equation are in exponential form, and the base of both the exponential terms are same, that is base is 1 plus r by 100, so we can equate the powers. So we have t is equal to 9. T is equal to 9. So the answer is after 9 years the sum will become 64 times itself. So the correct choice is B. B is the correct choice. Okay, let's do problem number 7. What is the compound interest on rupees 2,400 at 20% per annum, interest being compounded annually for a period of 6 months? What is the compound interest on? The principal is given to be 2400. The rate percent per annum is given to be 20% per annum. Interest being compounded annually, so U is given to be 12 months for a period of 6 months. T is given to be 6 months, means half year, half years. So when u is equal to 12 months, we know that r dash will be equal to r, which is equal to 20% per annum. Now we have to find, to use the general formula, we have to find the value of small n and the fraction a by b from the value of t multiplied by 12 divided by u, which is equal to t is half multiplied by 12 divided by 12, which is equal to half. Now half is equal to 0 plus half, 0 plus half, and 0 plus half. So this means it is 0 as a mixed fraction and half. So this implies that n will be equal to 0. N, we use the value of small n and the fraction a by b. So in this case, we have a by b is equal to half. So now the amount from the general formula we know is that 1 plus r dash by 100 to the power small n multiplied by 1 plus a by b r dash by 100. This is the general formula for the amount on the principal P, where for the principal on the principal P, the interest being compounded, where the unit of time is u, for a period of time t, for a period of time t, where t multiplied by 12 divided by u is equal to n and a by b. When t multiplied by u is expressed as a mixed fraction, and if the mixed fraction is n and a by b, that n and a by b is being used in this formula. So for this problem, we have found that n is equal to 0 and a by b is equal to half. So the formula becomes p. Also we have r dash is equal to r. So this becomes 1 plus r by 100. So this whole thing, n is 0, and 1 plus a by b is half, and r dash is r by 100. So this is equal to, this whole part becomes 1 because anything to the power 0 is 1. So p multiplied by, we have 1 plus r by 200. So this is equal to, p is 2400. 1 plus r is 20. So this is equal to 2400 multiplied by 1 plus 1 by 10. This is equal to 2400 multiplied by 11 by 10. This is equal to this is equal to okay, let it be like this, because we have to eventually find the compound interest. So the compound interest is equal to the amount minus the principal, the original principal. We know, so this is equal to, the amount is given, the amount we know is 2400 multiplied by 11 by 100, and 11 by 10, and the P, the original principal, is 2400. So this is equal to 2400 multiplied by 11 by 10 minus 1. So this is equal to 2400 multiplied by 1 by 10. This is equal to rupees 240. So the compound interest is rupees 240, and hence the correct result is C is the correct result. Okay, let's do problem number 8. The rate of interest for a sum that becomes 729 by 576 times itself in 2 years when compounded annually is. So we have to find the rate of interest per annum, so that a sum it becomes 729 by 576 times itself in 2 years. So if so if so let sum be P. So this implies the amount is equal to 729 by 576 into P, and we are having T is equal to 2 years. T is equal to 2 years. This implies so T is equal to 2 years, and uh, U is given to be, the interest is being compounded annually, so U is 12 months. So we have the special case where the interest is being compounded annually. So for that special case, we know the formula is amount is equal to P multiplied by 1 plus R by 100 whole to the power T, where T is the time period in years. Now this implies A is given to be 729 by 576 P is equal to P multiplied by 1 plus R is, we have to find R, so R is unknown, R by 100, and the T is given to be 2 years, so 2. We can cancel P from both sides and we get 729 divided by 576 is equal to 1 plus R by 100 whole square. Somehow we have to solve these to solve R from this equation, we have to somehow express the left hand side as a exponential term with the power 2. So with the power 2. Now what is the whose square is the so we have to express both the numerator and the denominator of the left hand side as a perfect square. So whose square is the number 729. So let's do a little bit of factorization. 981. Okay, and this is 9 and 9. Okay, so 729 is equal to 9 multiplied by 9 multiplied by 9. This is equal to 3 square, 3 square multiplied by 3 square multiplied by 3 square. So this, okay, okay, so this is 729 is 9 cube is equal to 9 cube. Now this is equal to 9 is 3 square cube. So I am using the laws of exponents, the concept of laws of exponents, to express the number 729 as a square of some natural number. So 729, as from the factorization, I know it is 9 cube. 9 cube can be written, the base 9 can be expressed as 3 square. So this is equal to, I can write 3 cube square, because from the laws of exponents you must be familiar with the concept that x to the power m, this whole raised to the power n is equal to x to the power n and then whole raised to the power m. So this is equal to 3 cube is 27, so 27 square. Okay, so 729 is 27 square. And what is 576? We have to also express 576 as a square of some natural number. 576, let's divide by 4. Let's divide by 8, 7, 56, 2, 8 and 9. Okay, so 576 is equal to 8 square multiplied by 9. This is equal to 8 square multiplied by 3 square. This is equal to 24 square. So divided by 24 square is equal to 1 plus r by 100 whole square. The left hand side can be expressed as 27 using laws of exponents. 27 by 24 whole square is equal to 1 plus r by 100 whole square. So in this equation we are having both the LHS and RHS in the exponential form, and the powers are same. So we can equate the base. So we have 27 by 24 is equal to 1 plus r by 100. So this implies r by 100 is equal to 27 by 24 minus 1. This is 3 by 24. This is 1 by 8. So this implies r is equal to 100 by 8, which is equal to 25 by 2 and 25 by 2 percentage. So the correct choice is C. C is the correct choice. Let's do question number 9. Rupees 2000 was lent at 40% per annum at simple interest for 1 year. If interest on it was at compound interest and compounded quarterly, then the amount obtained would be, okay, if the interest on it was at compound interest and compounded quarterly, then the amount obtained would be. From the first information, it is given that the rupees 2000 was lent at 40,000 per annum at SI for 1 year. If interest on it was at compound interest and compounded quarterly, then the amount obtained would be. Okay, so it is saying that rupees 2000 was lent, that is, was given to someone for 1 year at a simple interest, where the rate was 40% per annum. Now it is asking that what will be the amount if the principal is the same, that is the rupees 2000, and the rate percent is same, that is 40%, but now the interest will be compound interest, compounded quarterly, that is u quarterly means u will be equal to 3 months. So basically it has given that P is equal to 2000, T is equal to 1 year, the rate is given as 40, and u, since the interest is compounded quarterly, u is 3 months. We have to find the amount. Okay. Now u, we have to first find what is r dash. Now since t is 1 year, since t is 1 year, and okay, so let's see, r dash is r u by 12. This is equal to r u is 3 months to so this is r by 4. R dash will be equal to r by 4, and what will be, we have to find small n. If we want to use the general formula, we need small n and the fraction a by b, and which the small n and fraction a by b we will get from the value t multiplied by 12 divided by u, which is t is 1 multiplied by 12, u is 3. So this is 4. Now if we have to express 4 as a mixed fraction. So 4 as a mixed fraction is 4 and plus 0. So this implies that n, small n, is 4 and the fraction part a by b is equal to 0. Fraction part a by b is equal to 0 because t multiplied by u, t multiplied by 12 divided by u, that we represent as n and a by b, the mixed fraction n and a by b. Since we are having t multiplied by 12 by u is equal to 4, we can say that if 4 is expressed as a mixed fraction n and a by b, the fraction n and the fraction a by b, then n has to be 4 and the fraction a by b has to be 0. So now the amount, the formula, the general formula for the amount was t multiplied by 1 plus r dash by 100 to the power small n multiplied by 1 plus the fraction a by b r dash by 100. Now this is p, r dash is equal to r by 4. So this is r by 400 to the power n is equals to 4 and the fraction a by b is 0. So this part is 1. So this is equal to p is 2000 multiplied by r is 40. So 40 by 400 whole to the power 4. So this is equal to 2000 multiplied by 1 plus 1 by 10 to the power 4. Okay, so so if interest on it was at compound interest and compounded quarterly, then the amount obtained would be, the choices are given as more, less, more and less. So we have to basically compare the amount for the simple interest and the amount for the compound interest and then take the difference. And we have to find the difference. Okay, so for the compound interest, the amount is coming to be this. This is equal to 2000 multiplied by 1 plus 1 plus 1 by 10. Quarterly, okay. One plus 1 by 10 is 11 by 10. So this is 11 by 10 whole to the power 4. This is equal to we have to find 2000 multiplied by 11 to the power 4 divided by 10 to the power 4. This is equal to 2000 multiplied by what is 11 to the power 4. This is 121. 11 to the power square is 121. So this is 121 square. And we have uh, this 3 zeros cancels out and we have 1 by 5. So this is equal to 1 to 1 square by 5. This is equal to, how much is 121? I will again use the calculator. I'm sorry for this. 121 multiplied by 121 is this, divided by 5 is 29. This is 2928.2. The amount for the compound interest is rupees 2928.2. Now we have to find the amount for the simple interest. What will be the amount for the simple interest? We know in the simple interest, the amount for the simple interest, the amount is principal plus 1 plus RT by 100, where R is the rate of interest per annum and T is the period in years. So this is equal to 2000, 1 plus R is 40 and T is 1 by 100. So this is equal to 2000 multiplied by 1 plus 4 by 10, that is 1 plus 2 by 5, that is 1 plus 2 by 5 is 7 by 5. This is equal to 400 multiplied by 7. This is equal to 2800. So this is the 2800 is the amount based on the simple interest, and 2928.2 is the amount based on the compound interest. So we have to find the difference between these two. So this implies difference of amount, it has asked the difference, it has asked to compare the amount, then the amount obtained would be, that is we have to find the difference of the amount of the compound interest and the amount for the simple interest. So this will be 29, since the amount of the compound interest is more, we will have 2928.2 minus 2800, whatever this value will be, that more. So the amount of compound interest is more. So this is equal to 128.2 more. So the compound interest is more. How much more? It is by 128.2. So the correct choice is choice D. Sorry, excuse me, friend. Someone is at the door. Sorry, there was someone at the door. Okay, so let's do the last problem, that is problem number 10. Find the compound interest on 50,000 for 3 years compounded annually, and the rate of interest being 10%, 12% and 15% for 3 successive years respectively. Okay, so we have to find the compound interest where the interest is being compounded annually, but the rates are different for the different years. That is, for the first year the rate is 10%, for the second year the rate is 12%, and for the third year the rate is 15%, and the principal is given, that is 50,000, and the total duration time period is 3 years. So we know the formula for finding the amount where the interest is being calculated is being compounded annually, and for 3 years where the rate is we have some different rate for the first year and some different rate for the second year. So the formula is A is equal to P multiplied by 1 plus x by 100 multiplied by 1 plus y by 100 multiplied by 1 plus z by 100. So this is the formula for the amount on the principal P, where the interest is based on compound interest, where the interest is being compounded annually, and the rates are, for the first year it is x% per annum, for the second year it is y% per annum, and for the third year it is z% per annum. So this is the amount for 3 years. Now it is irrelevant, it does not matter whether the rate which percent is, whether the x% is for the first year or second year or third year. It could be for any of the first, second or third year. So if this formula will work when the percentage, the rates are x, y and z in 3 consecutive years, in 3 successive years, then this is the amount for the 3 years, on the principal P. So if we now put the values of the given for the given problem, in the given problem, if we put the values, P is the original principal P is 50,000. So we have 50,000 multiplied by x is 10. So we have 10 by 100 multiplied by 1 plus y is 12. So 12 by 100 and 1 plus 15 by 100. So this is equal to 50,000 multiplied by the first factor 1 plus 10 by 10. 10 by 100 is 1 by 10, and 1 plus 1 by 10 is 11 by 10, multiplied by 12 by 100. Let's keep the denominators of 100. So this will be 112 by 100 multiplied by 115 by 100. So in the denominator we have 10 to the how many zeros? We have 5 zeros. We have 5 zeros. So we can cancel 4 zeros from the 50,000, and 4 zeros cancels out from the denominator. 5 cancels 10, 2, and 2 divides 112 with 56. So the answer is 11 multiplied by 56 multiplied by 115. I will again use the calculator. I am sorry for this, but this kind of calculation you should be doing it manually yourself. So 11 multiplied by 56 multiplied by 115 is equal to 840. So the amount is 70,840. So the correct choice is B. B is the correct choice. So with this, it comes to an end in solving the 10 good problems on the chapter of compound interest based on all the concepts that I have already discussed in the other playlist, that is CBSE Maths 8 R.S. Agarwal. I hope this set of 10 problems will give you a good practice of your concept, and it will also evaluate your understanding of the chapter concepts. So if this video was beneficial, please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will keep on making this kind of 10 good problems from this chapter as and when I will progress in the other playlist, that is CBSE Maths 8 or CBSE Maths 8 R.S. Agarwal. So please keep an eye on this playlist. Also, in the other playlist, that is CBSE Maths 8 RS Agarwal, the next topic on the chapter of compound interest will be the applications of compound interest in real world scenarios like the growth of bacteria or population or some and more. I will. So please stay tuned for that video also coming soon. So that is all for this video. Thanks for watching, and until the next video, take care and bye.